It's my pleasure to invite our next speaker, Mr. Peter Saddington, Business Development Lead, Enerlytics, which is the industrial IoT platform for the energy industry developed by Uniper. Recently, he and his team helped a power plant in Australia improve its competitiveness and reliability by using state-of-the-art digital solutions. Prior to joining Uniper, Peter was the commercial manager for the built environment sector at BSI, working with global clients to understand their changing needs and providing solutions tailored for them. Please welcome him on the stage.
Thank you all for coming and for inviting us to talk. My name is Pete Saddington. I'm the Business Development Lead for Enerlytics at Uniper. Today I'm going to be talking to you about digital retrofits for efficiencies on your power plant. But in order to explain a little bit about Uniper to start with, and I'll also explain the challenge that started us on this journey as well, how we've solved it, and some of the key benefits of doing so. So I'll give you some real-life key benefits and case studies where we've seen some financial gain. I'll show you this in practice as well, and I'll also talk through selling this to your stakeholders, because adopting a digital strategy is a challenge for any business. So we'll explain how we've done it and how we've managed to get some of our stakeholders involved, and then we'll summarize at the end. So a little bit about Uniper to start with. You may not be familiar with the name, but we are the 4th largest energy generator in Europe. We operate in over 40 countries around the world, and we have an installed capacity of about 38 gigawatts. We employ just under 13,000 people. The majority of those are in our power generation business, but 4,000 or so are engineers who work for our engineering services business, and this is the part of the business that we offer globally. We also have a small team who work on commodity trading and energy sales as well. So our operations are mainly around power generation, commodity trading and energy storage, but the part of the business that I work for is supporting people with engineering services for energy services. And within that team, we have a small team dedicated to building digital solutions, and they've been in our team for a number of years. So you may not be familiar with the name Uniper, but you will be familiar with some of the names in our history. So our company goes back over 100 years, all the way back to Inverca in Germany. More recently, you'll be familiar with E.ON, who we were divested from in 2016, and PowerGen before it. In the UK, our origins are based in the UK Central Electricity Generating Board, or the CEGB, as you may know them. And some of the experience and expertise that we have. So because we have a background as an asset owner and operator, it gives us a really good understanding of what other owners and operators are looking for, and it helps us understand your problems a lot better. We're independent of equipment and component suppliers, and this gives us the freedom to give you the best advice for you as an energy generator, rather than potentially for an OEM. And where we offer software and services, we look to do it in a tailored, personal manner. So we don't look to just give you a solution and move on to the next customer. What we try to do is work with our customers, understand their concerns and their market, and really try to add some value to their process as well. So the challenge and why we at Uniper looked at digital and why we did it now. So the best thing I could do is give you an example of what we found. This is a day in October last year in the UK. So we had a relatively low carbon intensity. Where we have quite high renewables penetration in the UK, and it's usually quite reliable, is because it's often offshore, well, most of it is offshore wind. But on this particular day, the wind didn't blow. So CCGTs were making up the balance. There was also a coal unit, which was actually our coal unit as well, providing non-energy services to the grid, so providing inertia. And there was a part where the wind completely dropped and the standby generators for the grid kicked in. You can see here that the gas set the UK market price for the most part on this day. And we were also exporting some electricity out to France and the Netherlands, where we have interconnectors as well. But this can change. And what this gives rise to is an opportunity. So while we have quite high renewables penetration, there is an opportunity there for traditional assets to operate more flexibly and take advantage of market opportunities while we go through this energy transition over the world. Now, I've been here all week, and I've had some meetings with people, and one of the prevailing bits of information I've got is that people are unsure about how renewables will penetrate in this industry. Well, I can show you here that this is the first 50 years of operating one of our units, and the number of starts goes up the top. So early on, we had very little flexibility in the market, but then we had the miners' strike in the 1980s, and then we started moving as a country towards gas units. So we saw a lot more spikiness in the number of starts that our units had to make. And then in the 2000s, where we've seen renewables really penetrate the market, particularly offshore wind, we now have solar coming in a big way in the UK. Not that we have much sun. What we're starting to see is that our units have to operate in a very different way to how they were originally designed for, and that gives rise to a number of different problems. So you can see the challenge that we face. And as a result, at Uniper, we have a saying, no wind, no sun, no problem. We're there to help support the energy transition and also provide safe and reliable generation for the grid. But in order to do so, and to do so safely, digital is really, really important to this. And having some digital solutions is one way we've found of really being able to manage this and do it successfully, so much so that we are one of the largest generators still. So to talk a little bit about the history of digital, it's not something new for us. We've been doing this for a good 30 years or so. So going back to our CEGB days, we started doing thermodynamic modeling. In the very late 70s, we wrote our Pro 80s thermodynamic modeling suite. And then about 25 years ago, we started looking at the vibration monitoring, so the online vibration monitoring of the main shaft line in the power plant. We then started to see the change in the market conditions, so we started looking at applying some digital solutions around complex market modeling, taking into account a lot of the different constraints we were seeing at the time and the change in the market in order to maximize our financial gain. And then about 15 years ago, we started taking a more holistic look at risk. We've always taken it seriously. Being a German-owned company, we are very risk-averse naturally. But we've started to have to look at how we mitigate those risks and really take calculated risks to remain profitable and remain viable. And that's where we started applying some of our risk management tools. And then 10 years ago, we started looking at advanced condition monitoring. So not just looking at the vibrations, but also the auxiliary systems on the plant to really understand how we can operate our units in a safe manner, but also flexibly at the same time. And then more recently, we've started looking at maintenance optimization. So applying a different maintenance strategy to each component on our plants in order to maintain availability when the money's there, but also to maintain our assets in a safer manner with them operating flexibly. Most recently, what we've drawn all of these together into is a single platform, and it's called Enerlytics. And the reason for this, I'll explain here. So the gentleman who was talking before me mentioned that often systems are held in silos, but often a lot of people will use the same data. And we found this on our plants. We were using the same data in different teams, but they weren't sharing the results. So what we've done with all of these different programs is place them in the same place, added in the manual monitoring that we take as well on site, and that gives you all of the information that the conventional systems provide, but it also presents it in a single platform. Now, across these different applications, we've now been able to write them so that they talk to each other, so you can share the output from one to the next and gain the maximum amount of benefit for your plant. So when we've set this up on our sites, we have everything in the central dashboard area, so all teams can benefit from the information. So, for instance, the maintenance team, who are planning their strategy, can see any issues that are occurring with the condition of the equipment on site. They aren't just told what the problem, or that there is a problem, they're told what the problem is and what they need to do to fix it. So it supports that decision-making process as well and really adds some value and creates some efficiencies as we go through. Some of the benefits we've seen on our plants and also at other customers' sites. So from a maintenance strategy optimization point of view, we're able to reduce the outage time and the overall expenditure between 10 and 15%, depending on the site. And when it comes to the amount of Capex, usually there's a 10 to 20% reduction as well. On our coal sites, we've been able to use our performance management tools in order to reduce the fuel oil required on warm startups by between 15 and 30%. And we've seen where we've had our condition monitoring put in place, a 56% internal rate of return with a payback time of roughly 6 months. So where we're making catches, we've been able to quantify what those would have cost and then been able to demonstrate that it's paid for itself within a very short space of time. On some sites, so in the introduction we mentioned a site in Australia, which was a particularly dirty site, if you like. We've been able to support their performance and manage the condition better, which has given them efficiency gains of around 1%. Now, that's not going to be the case on every single site, certainly not on gas sites, but it's certainly something that we've been able to support on a number of sites as well. So how we've done it, these applications are put on a platform, and as I said before, they do talk to each other, so they are a smart solution. And really, I'll talk you through each individual one and how that they interact with the others. So we start with asset maintenance and reliability. We have performance tools as well. We also look at market optimization. And then we have some tools around asset planning and valuation, and then risk management as well, which is absolutely key. So starting with some of the performance tools, we have a thermodynamic modeling suite, which is powered by Pro80s, which is our own proprietary engine. This gives a physics-based whole plant model, which allows you to assess the overall plant performance. It also allows you to look at the individual plant components and see how they interact with others. It maximizes the efficiency of the plant and then ultimately the generation as well. Some of the technical strengths of this, it works with residuals, and it utilizes an optimization to give more realistic results. It also allows what-if calculations to be made, so operators can make a calculated risk when they make changes on the plant and know how it's going to perform. So a couple of case studies where we've seen real benefits from this. So this was the site we're unsure if adding or removing a cooling tower would improve the output of the plant. What you can see here, although it's not very clear on the big screen, is the site we're able to see that by adding a cooling tower in the morning, the performance would increase, which was then backed up when one of the cooling towers was dropped later in the day, which is the white line at the top. And you can also see that decreased the performance overall. So they were able to make that assumption and then check it in the system before actually making the change on plant. Another example is our online monitoring of thermodynamics picked up a pressure drop, and the site needed to understand the best route, whether it was more cost-effective to take the site offline as an unplanned outage and fix the problem, or whether they could afford to run to the next planned outage. Using our thermodynamic modeling tool and the condition monitoring tools as well, talking to each other, we were able to justify that there was a 0.5 megawatt output impact, and that the site were able to see was more cost-effective to run to the next outage with that loss than it would have been to take it offline and fix the problem there and then. So again, being able to remain available when the money's there, it was able to demonstrate that. So our performance tools give plants essentially the opportunity to use some of the big data that sits behind it to performance manage certain functions and certain parts of the plant. It can offer actionable insights as well. So where you have a particular problem, you can start to use the reporting to manage it out over time. And it's really important to note that a lot of these issues are done manually, but with the help of the system. So the system acts as a support. Ultimately, it's there to watch your back, not to look over your shoulder, which is sometimes a concern on plants. It also allows us to monitor and assess the performance of individual assets and then compare them against others in the fleet as well, so you can do some benchmarking activities. And it helps to drive down the cost of startups and increase the output as well. So one of the examples, which was on one of our coal sites, it was the example I showed you before where we've had to operate more flexibly, probably more so than any other site. This example was the fuel oil had a certain cost, and when you're starting up once or twice a year, the fuel cost is negligible. When you're operating, starting once or twice a day, that fuel cost becomes a huge issue, and it can make the site unviable. So by using the performance tools, the site were able to see where they were using the fuel and how much they were using, and then over time start to bring that down at a lower temperature. So you get a much more standardized use of fuel oil, and it also brings the amount used down as well. So by tracking that over a period of time, I believe it was about 6 months, the site were able to bring the amount of fuel oil down to the point where they were saving roughly around 25,000 euros per startup, which equated to 3 million euros over the course of the year per unit. So a huge amount of savings, which made the site more viable. And to this day, will probably remain one of the last will remain the last coal plant operational in the UK. Another example, this is from our colleagues in Australia. The plant are a mine mouth facility, and they were experiencing erratic temperatures in their boiler. And it was causing excess fouling, particularly around the top of the boiler. They were doing regular soot blowing, but this wasn't resolving the issue. So what we did is we used both the thermodynamic model that we had of the plant, and then we fed those results into the performance tools. And we were able to see although the diagram doesn't show it particularly well, that there were two particular mills that were biasing the fuel in an incorrect manner. They should have been biasing it 60% towards the bottom, 40% to the top. What they were actually doing was doing closer to 70% to the top, and that was causing the fireball in the boiler to move and causing the excess fouling. In addition to that, we also picked up a condition monitoring issue where we identified that on the fifth mill, when it was due to be closed, the seal was broken because the temperature was still the same as if it was open. So we were able to identify a real issue there as well. And in the next planned outage, they're going to be making some changes and some fixes to that. Also changing the biasing on the mills as well to maintain a stable boiler temperature and not cause the excess fouling as well. Our condition monitoring tools aim to provide total plant coverage, and we do this through using a machine learning algorithm that we've written ourselves called Spherical. It's a multi-dimensional model, and I'll explain a little bit about how it works now. So if you take a couple of dimensions, so in this case temperature and load, what we do is we train our model on good operational data from the plant, and we take that from the DCS system, but usually via a historian. What we then do is we map out good operation, and then you can add in as many different, gone off again. You can map out many different model dimensions as you want. In this case, we've added pressure, but we have a model that has 46 different dimensions. I'm not sure how we draw that, though. What we then do is monitor this all the way through the process. And the reason we do this per plant, there's two very good reasons. One is ambient conditions play a huge part in it. So every plant operates differently, even if they have the same equipment. Secondly, what we try to make sure is that essentially, even if you have a change in maintenance or the change the way the plant is maintained, this process remains the same. So it's really important to keep an eye on these things. What we then do is we'll build alert limits around this. And then if operation then goes outside of the normal area, it will alert the nearest one. Now, a lot of systems do this. This is not anything groundbreaking. What is different is what we do with it. So at the moment, what happens is once we get that alert, we will then send that to our monitoring centre in Ratcliffe in the UK. The team then identify it, so they're plant experts, and what they will do is they will have a look at the alert. They'll then do a first stage diagnosis and then send that to plant. So rather than sending an alert, which could be a signal failure, direct to the plant, what we do is we say, you've got this alert, this is what the problem is, and this is what we believe you need to do to fix it. So again, it provides that decision support as well. So we have a few case studies. This one is a really good one. So the plant had a turbine that was coming back from a long-term overhaul. Startup vibration was flagged by the OEM, not just once, but twice, who were also providing monitoring services as well. Both times, the plant took the turbine offline and found nothing wrong, and we had said, this is just startup vibration, it's nothing you need to worry about. The third time, the OEM told them they had to take it offline again, and the site said, no, we don't believe you, we've lost all faith, we're going to continue to run. However, what we'd also picked up was not just high vibration, but also a high temperature as well. And what our team were able to diagnose was that that was likely to be a loss of mass on the first stage rotor. By telling the site that and making them aware in an urgent manner, they were able to take it offline, investigate, and they found that they hadn't put a locking wire back in place, which had caused the blades to shear, which could have caused catastrophic damage to the entire turbine, saving millions of pounds. So providing that additional information and decision support allowed the site to make a better decision than just if they had vibration monitoring information. Another example is where a transformer was displaying a high winding temperature. We alerted the site, and they were able to see that there was a safety cordon actually around this piece of equipment, and debris had collected on the top. They were then able to go and get a permit, go in and clear it off, and the winding temperature went back down to usual. If it had been allowed to continue, it would have caused a trip. And then another issue, a potential air heater blockage. You can see on the left of the diagram that this is where the issue had caused the unit to trip, and then we'd started monitoring just after that trip. So you can start to see the issue starting to happen again where it says consistent error. Now that was within the DCS alert limits as well, so it was just a note that our condition monitoring team made to the site to say you might want to see this because it's going to happen again. The site were very grateful because it meant that they could include this in a planned outage in a few weeks' time, thus saving them around about €300,000 that they reckoned that they would have lost through an unplanned outage and lost generation as well. So using all of these tools, what we're able to do is start to look at the maintenance strategy around our units. And the reason we do this is to make them available when the money is available as well. So what we now do is we start to look at all of the individual components and apply the right strategy for them. So whereas we would have normally operated, say, a time-based maintenance strategy on our steam turbine, because we're operating flexibly, we're able to apply the EOH concept, or the equivalent operating hours, which is traditionally seen in gas, and move that across to here. What we're able to do then is start to build in commercial data as well, and then additional information around what Capex we're going to have available, and then build that into our business plan. And as a business, we do it over a midterm period, so we do a 3-year business plan. And that then becomes our maintenance management system. So the example here is we saw a 16% reduction in the Capex at a number of our sites. And the old MTP had, I believe, 7 planned outages in 2017, had 4 in 2018, and then 5 in 2019. We were able to move them out at all of the sites, so those 3, which meant that we had a much more stable profile going into the future, and we were able to generate more as a result as well. So there's some of the examples of where we've seen real benefits from adopting a digital strategy. But selling this to your stakeholders is slightly different. Digital is a different process. It is more intricate. So a few of the tips that we've found selling this within our own organization, I'm going to share with you now. So the value on each asset is very different. So the value you will find from a digital strategy on a brand new gas CCGT plant is very different to what you'll find on a very old, unmaintained coal plant. So digital can deliver benefits in a stepped manner. And as a result, the most important thing to do is to take case studies. So as you go through, focus on a single asset at a time, prove the value, and then move on to the next one, because that is much more palatable to a business than showing them all of them at once. It's also more workable as well, because there's only a finite amount of resource every business has to do this, because it will be on top of business as usual. Another key difference here is that digital is engineering, or rather, digital is nothing without engineering. It's very good to apply digital thinking to these processes, but what's really important is that you have the correct engineering knowledge behind it to support those decisions as well. So that's where we've benefited from having 4,000 strong engineers, and our customers also benefit from that team of support as well. And ultimately, the idea would be to deliver from engineers who have digital experience rather than just deliver from a digital team that has no plant experience as well. So to sum up, a few of the high-level benefits of the solution types, and we'll look at the difference between base loading and flexible operation. So from a maintenance point of view, when you're base loading, you're essentially looking to maintain availability full stop, whereas at flexible operation, you're looking to maintain availability within the money, so when it's there. Operation and production-wise, you're chasing the megawatt hours at base load, so to try and get the maximum output as possible. But with flexible operation, you're chasing the money, so it's maintaining that availability in that stage. And then when you look at the different solutions, thermodynamic modeling is incredibly important when you're base loading because it helps you identify particular issues. And when you're operating flexibly, it's slightly less because you're operating at different loads all the time. Vibration monitoring becomes slightly more important when you're operating flexibly because you're asking pieces of equipment to do what they were never intended. And risk management also becomes slightly more important because you're taking more calculated risks by operating equipment that was never intended to be operated in that way. Advanced condition monitoring then becomes absolutely critical when you're operating flexibly because it allows you to identify issues at a much earlier stage and then make calculated decisions about what you want to do when it comes to the maintenance strategy. And performance also becomes more important because it's about maximizing your output when the money's there as well. And then from the last point of view, maintenance optimization, it's important to make sure that you're on the right maintenance strategy when you're base loading, but ultimately when you're operating flexibly, the real key is to optimize that maintenance around being available when the money's there as well. So to sum up, a few key points and a few takeaways. Renewables are happening. We're seeing this more so in the UK than maybe Germany, but Germany is also seeing it too, as is the wider Europe. And this is something that is starting to happen closely across the world. So while renewables is happening, reliable generation is needed to deliver a safe future as well and to provide a reliable supply. Digital solutions can provide benefit, and they take time to implement, but ultimately, they will provide a different amount of benefit on different units. So it's important to take a holistic view when looking at the value case. Digital delivery is different to standard delivery. The projects work in very different ways, so it's important to recognize that and take that into account. And ultimately, what we've tried to do as a business is remain as profitable as possible, and I'm sure all energy generators will want to do the same. So I leave with a note of do or be done to. So take the initiative on this, start to apply it, because it's much easier to do at an early stage than it is to try and do while you're catching up to competitors. I'd like to thank you. If you want to come and have a look at how the system works, we have live demonstrations on our stand. We also have an office in India, which we've recently inaugurated, and you're more than welcome to visit us and our team there. It's in Noida. So I'll leave that up if you want to take a photo, but please do come and have a chat to us afterwards. Thank you very much.
Thank you again.
Thank you very much.
Thanks for coming
No,
all the way.
thank you.
Thanks for coming.
Cheers.
Excellent.
Thank you very much. Thank you.